Orbit. Pocket so fat, call me Orbit. Orbit.
Ever wondered what the physics behind basketball are? Basketball would not be a successful sport if it wasn't for the different laws of physics. One important law is Newton's first law, which is an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction until the object is acted upon by an unbalanced force. In basketball, an instance of constant velocity is running. In order to calculate velocity in meters per second, we create an example equation. Say that a basketball player starts at one end of a court at 0 meters. What is the player's velocity if it takes him 8 seconds to travel 20 meters? By using the equation of the final position equals velocity times time plus the initial position, we got that the basketball player has a velocity of 2.5 meters per second. Forces can change an object's speed as well as the direction in which an object is moving. In these relevant force diagrams, we created one with all the forces affecting a person, and the second one with all the forces affecting a basketball. When a basketball player shoots, it would appear that there is nothing to obstruct the ball. However, there are several forces acting upon the ball. Without these forces, the ball would continue to travel in its current direction. First, gravity acts upon the ball to pull it down to the earth. The athlete must see the force of gravity by the weight of the ball in order to find the right line of trajectory so that the ball arcs into the basket. Another very important law in physics and basketball is Newton's second law, which states that acceleration is produced when a force acts on a mass. The greater the mass of an object being accelerated, the more force needed to accelerate that object. The equation is expressed as force equals mass times acceleration. The acceleration of a basketball player jumping straight up into the air is 9.81 meters per second squared. It's a lot of bad things that they wish and they wish and they wish and they wish and they wish on me. Friction is a resistance on two moving objects that touch. There is static friction, the friction before an object begins to move, and kinetic friction, the friction of a moving object. Friction opposes the motion of two objects when they come in contact with each other. In this case, friction between the player's shoes and the basketball court keep the players from sliding. The coefficient of friction is the minimum force that is needed in order to cause an object to move along a surface, divided by the forces that are acting upon the object. Volleyball is similar to basketball in many ways. Both sports involve friction as their primary force to play. There needs to be enough friction so that you can fully stop your feet at the right position to pass the ball in volleyball. Or, in basketball, you have to stop your feet in order to shoot or pass. The calculations for the weight of both a basketball player and a basketball are equally important. To solve for weight, use the equation F of Earth on an object equals the mass of an object multiplied by negative 9.8 newtons over kilograms.
This is Frank Feliso, and we're interviewing him for our physics project. When did you start playing basketball?
Basketball when I was about 5 years old.
What is your favorite part about being a part of a team?
The brotherhood, you know?
Oh yeah, the
It's
bonds.
like homies. My best friends are on the basketball team, so it's the bond. Yeah, the bond. James Bond.
What aspect of the game comes easiest to you?
Passing, because I have really good players on my team, like Dylan and Alex.
What was the most exciting game and why?
Probably the Pally game, even though we lost, because we went to double OT, and they're like one of the best teams in the state, and we almost won.
What has basketball taught you that carries over into the other areas in your life?
How to be a part of a team and use everybody's attributes to our advantage. I don't know. How to be a good person because I'm a good teammate. And like, they are together somehow.
Well, that's it for today, folks. Catch you on the flip side.
As you can see, there are many parts of basketball that need the laws of physics in order for it to be a successful sport. Without physics, who knows what we would be doing for fun.